So let's begin with this homework assignment 6. Anybody, any question from section 2.3? I sent you a message asking you to review my feedback and on your assignment and have your questions ready. Unless you got 100, you got something wrong, then you had to ask that question and make sure you understand it. Because the questions on the test will be similar to your questions on the homework. All the questions on the homework, you should go over and make sure you know how to answer them, because test will be very similar to them. All right, so no question on...
Professor, can you go over 6B?
6B, okay. Then okay, going over 6B, which says in problem number 5. Hold on 1 second. The students are still coming in. Okay, number 6 says in problem number 5, use int a equal to 3, b equal to 2, c equal to 2, and recalculate the values. C equal to -2. And you wanted b. All right, b is 10 minus c times c, 10 point minus. So part B says 10 point minus c times c. So the c times c will be done first because multiplication is supposed to be done before subtraction. So c times c, which is -2 times -2, will become a 4. So you have a 4 right here. After that, 10 point minus 4 will be done, which will give you 6 point. So 6 point or 6.0 is the correct answer. If you miss the decimal point, you only get partial credit. Decimal point matters in computer programming. And so whenever the answer is a 40 point number, you should include decimal point. Anything else?
Can we go over 4B?
4B, okay. 4B says it's 4.0. So that's a floating point number times 3/2. So here, if the parentheses is not there, then the multiplication of 4.0 by 3 will be done first. But the parentheses is there, so 3/2 will be done first. 3/2 will produce a 1, not 1.5, because 3 is integer, 2 is integer. If you remember, integer divided by integer will be integer part of the answer. So it will only give you a 1. And 1 multiplied by 4.0 will be done next, and that will produce a 4.0.
A quick question, because I came across this for the review questions too. So if there's a long like arithmetic for you to do, you have to evaluate every time you do something between two numbers, you have to evaluate if it's an int or a float, and then decide what the answer is going to be before continuing.
Exactly. You had to look at the data type of both operands. Here, the both operands are integers, so the answer will be integer. If one of them is a float, the answer would have been float. So, yes, you have to pay attention to those details. This is called the computer arithmetic. Computer arithmetic is slightly different from the arithmetic you learned before. Anything else from 2.3? Okay, moving to 2.4. Whenever the problem tells you to write the output, you only write exactly what is expected to see on the screen. Do not write anything else. For example, in this problem number 2, there will be two numbers. There's the last line says C out X, ENDL, C out Y, ENDL X, and then ENDL N. So there are three numbers you're writing. So, and those three numbers are going to be on three separate lines. And you must write them exactly the way they are. And do not write X equal to this, Y equal to this. Only if system is going to write X equal to something, then you need to write that. Otherwise, just write what will show up on the screen. So here there will be three numbers written by these last cout statement. There's another cout statement earlier that's going to write the number exactly the way the user entered, the number entered by the user. So the output for number 2 will be this 2.4, section 2.4, number 2 will be 7.43. That's the number user enters. It'll write that number on the screen. And then it will write X over 4, X is a float. So that's 1.8575. That's what X over 4 is. And also it'll write the integer part of that. That's 1 point. And then writes the value of N, which is, from what I remember, 0, I believe. 0. 4 numbers will be written. So you have to write them exactly the way they show up, one below the other. So this will be the output. So if it is a test question, there'll be a space that says, a box that says output. You only write these in there, in that box. All right, anything else?
Can you do 6, Professor?
Number 6, okay. Yeah, today is pretty much, answering your question and going over anything you want to need to go over. Write a program that obtains number of nickels and dimes. All right, let me clear the screen. We're going to get nickels, dimes, and quarters, and then write how many coins were there, and also write the dollar value of that. So whenever it says write a program, you have to begin with main. In the test also the same. You don't need to write anything that we normally write before the main, things like pound include IO stream and using namespace, all that stuff. You don't need to write any of that. You begin with main. We can always assume that you know what goes at the top, but you don't need to spend time on that. So just begin with the main and the curly bracket and write the body of the program. So here I need variables for nickels, dimes, and all that. I'm going to make them float because I know that the value is, make them int, but we have to make sure that when we calculate the value, it's going to be float. We have to make sure that it will be float. So these coins, number of coins can be integers. So I'm going to keep them int nickels, dimes, and quarters. Nickel, dime, quart stands for quarters. And then, yeah, that's all we need, integers. So the next thing I need to do, I also need a float type variable to hold the value. And that's the number of coins. So I'll call it coins. That'll be integer. Add that as integer variable. Okay, so next thing is to get the data. Without data, we can't do any calculation. So first thing you need to do is get the data. So ask the user to enter number of dimes, quarters, and nickels, all that, separated by space. You need to say all that, separate them by space. Because when you're reading many things using one CN statement, user will have to enter them separated by space. So nickel, dime, quart, and that's it. And I'm ready to do the calculations. First thing I need to do is coins. Number of coins will be just the sum of nickel. Nickel stands for number of nickels he entered. Dime stands for number of dimes. Quart stands for number of quarters. And so that finishes the calculation of number of coins. Next, I need to calculate the value of the money. The value of the money, and I also have to make sure it is, okay, there was one student who wrote this way. I'm going to explain that. I think two students wrote it this way. Nickel, which is the number of nickels, you divide it by okay, so you divide by 20. So instead of using decimal numbers, he was using division. Okay, so dime stands for number of dimes, and you divide by 10. And you divide quart by 4 to get the dollar value. You know, that's what he was writing. Now, this is wrong. Anybody see what's wrong here? I gave the credit because I knew that the student didn't realize that this is going to produce wrong answers, but I gave him the credit anyway. Anybody recognize what's wrong here?
The nickel, dime, and quarters is stored in a integer type data.
Right, and you're dividing by integers. So when you divide integer by integer, you're going to get only the integer part of the answer. You're going to lose all of the fractional numbers here. So that's completely wrong answer you're going to get. The student didn't realize that. He wrote that. So if you're writing it this way, you had to write 20 point, 10 point, you know, I wouldn't even bother to write that way. Why bother? The value should be written as nickel times 0.05. That's what the value of a nickel is, $0.05, right? And dime is $0.10 plus quart times 0.25. You know, straightforward. Anybody can follow this easily, and also the value will be coming out right, because even though nickel, dime, and quart are integers, the 0.05, 0.10 are float numbers. So therefore, correct value will be computed. So value will be correct with this expression. So I only need to present the answers now. See out number of coins equal to coins. And then ENDL, because you want to put the next thing on the next line, value equal to value. And then close the program. That will be the complete program. Okay, anything else?
Professor,
Right.
Professor, one question.
Yeah.
Don't we need parentheses between each of the multiplications, or would that be fine?
No, I don't, because remember we learned last class or the previous class, the order of operations, the multiplication will be done before the plus, right? Before addition.
Yes.
Therefore, this multiplication will be done, and then this multiplication, and then this multiplication. Only after that, this plus will be done, and this plus will be done. Okay, so we don't need parentheses. It will be done correctly.
Thank you.
Professor?
Is it wrong to put parentheses? It's not wrong, but it's going to look kind of complicated, unnecessarily complicated when you put too many parentheses. Yeah, okay. Go ahead, Benjamin.
So, my biggest issue with writing the code, it would be like always writing like the equations.
Yeah.
Do you have like a certain method of like writing it like more easily, or like thinking of how to write it? Like a process? I don't know.
There is no technique, this just now this expression, for example, what seems to be complicated about this?
No, it's not this one specifically, but like once like we get more in depth, I like what do
Maybe
you call it?
problem 8. Problem 8 has this algebraic expression. Is that what
Yeah. I wouldn't know how like to create that.
Okay. All right. So I'm going to write that just that expression, converting it to C++. It'll be float variable y. No, I mean, the answer has to be float. I'll call it ands. And then ands equal to, the numerator has 3x squared. So that has to be 3 times x times x. Okay. No, there's no exponent in C++, so everything has to be multiplication, plus 2 times x times y. I know that the multiplications will be done before the addition, so I don't need parentheses here. Plus y times y, that's the numerator. Now, this entire numerator needs to be divided by the denominator. So if I put a slash now and write 3, I'm going to end up dividing only this y by 3. See that? So that's why I need parentheses for the numerator to say divide the whole thing. So I need this parentheses. Otherwise, I will end up only dividing the y. So, and then denominator is 3xy. Now, if I just write 3xy like that, 3 times x times y, then the division of this entire numerator will be divided only by 3. Remember the order of precedence? If there are multiplication and division, it will do left or right. So it will do this division before these multiplications of x and y. So you will end up dividing by 3, which is wrong. So therefore, only if you put parentheses here, it'll do this multiplication of 3xy and then do the division. See, parentheses are supposed to be done first. So everything in the numerator is in parentheses, so it'll do all of that first, and then it'll do all of the denominator, and it'll do division at the end. That's exactly what we want. So that's why these parentheses have to be introduced.
Oh, okay.
Okay.
Thank you.
You're welcome. Anything else?
Can you do number 8, please?
Number 8.
Yeah.
I didn't hear you. Maybe you should increase the volume.
Number 8, yeah.
Number 8 right here in section 2.4.
Yes, sir. Yeah.
That's what I wrote the expression for. So you want to see how the complete program will be written?
Yes.
Yes. Okay. All right. Then let's clear this. Okay. Write a program that will interactively obtain the values of x and y, and it'll calculate this, and it'll round the answer to 2 decimal digits and display it on the screen. Okay. So let me write the statements for the program first. Number 8. Start with the main and introduce the variables. We need float, x, y, and answer. Okay, to do the rounding part, I need an integer type variable. I can do without it, but if I use it, you will understand better. So int z, semicolon. And then we are supposed to get the values of x and y from the user. So therefore, I need to ask the user to enter values for X and Y. And so you have to elaborate that a little bit and say, enter the values of X and Y separated by a space. C in X, Y. So you can read both using one scene statement. And now I need to calculate the ands. So I already explained how to write that. So I'm going to go ahead and write that. 3x squared plus 2xy plus y squared. Quantity divided by. If I need to, I can go on to a new line, no harm done. 3 times x times y. Because as long as there's no semicolon in the first line, it'll know that both lines together is one statement. Okay, so now the rounding part. So to do the rounding, I'm going to explain on the side. If I have, for example, this rounding you were supposed to do in the homework, the project also. 6792 as opposed to 27.6742. You're rounding at the hundredth. Let me see, 2 decimal digits means hundredth. So right here, this 7, this is where you're rounding. That means the next digit is 9, which is over 5, and therefore your rounded number will be 27.68. So we have to write statements that will do that. So the statements I write should convert this number to 27.68, this other number to 27.67, because the digit next to it is 4. So no matter what the number is, your process should work correctly. I explained this in class, but I'm going to explain one more time. To do that, the rounding, you have to first move the decimal point next to the 7 right here, because that's where you're doing the rounding. So to move the decimal point, I'll multiply by 100. So first step is to multiply by 100. It'll become 2767.92. And in this case, if you multiply by 100, it'll become 2767.4. And when I add 0.5, whenever this digit is more than 5, when I add 0.5, it'll automatically end up increasing the digit before that. So adding 0.5 would make it 2768.42. In this case, adding 0.5 will make it 2767.9. As you can see, this digit 7 didn't change here, but here it changed. Okay, after that, you take integer part. That'll give you 2768 in this case. Here it'll give you, if you take integer part, it'll give you 2767. And so we have already rounded, but now we need to put the decimal point back in place, back next to 7. To get that decimal point, I have to divide by 10. I have to do that here. Divide by 10. But if I divide 2768 by 10, integer 10, it'll be 27. I'll lose the 0.68 because integer divided by integer is integer. So that's why I had to divide by 10 points. Then it'll be 27.68. And if I do the same here, divide by 10 point, it'll be 27.67. So as you can see, we have the rounded number, 27.68 in this case, 67 in this case. That is our rounded number. So the process is to multiply by 100, then add 0.5, then take integer part. So I'm taking ands here, multiplying by 100 first, and then adding 0.5. And then to take integer part, I can assign it to integer variable, which is what z is, z. And after that, after taking integer part, we need, if you go back to the process, here, this is the integer part, and then I divide by 10 point to get the final number. So z divided by 10 point should go back to ands.
Professor?
Yeah.
Wouldn't it be divided by 100?
Oh, I'm sorry, 100, you're right.
Yeah, okay.
I just explained in the other class, rounding at the 10th digit, so I was still using that. So yes, we multiply by 100, so now we have to divide by 100 to go back to that. And after dividing, I had to put it in ands, not in z. Z is integer type. So ands. And also you have to make sure it's 100 point, because z divided by 100 is going to give you integer part of the answer. You'll lose the fractional part. So make sure it's 100 point. So yeah, I wrote 10 here, that 100 point, 100 point. Okay. So that'll give you, move the decimal point back, and the answer has now rounded answer. And you see out that. Okay, can we do this rounding business in one step? Yes, I'm going to write that on the next line. Instead of these two lines, I could write this. I could say, take ands, multiply by 100, then add 0.5, then take integer part of that whole thing by putting int in front of it. Here I use the z assigned to z, but instead you can just use the operator int to get integer part. Then the next step is to divide by 100 point. So divide by 100 point and put it back in ands. So same thing, I did it in one line, one step. So that's rounding at the near, rounding at the 100th. So if you're rounding at the 10th, then instead of 100, you had to do 10. You had to multiply by 10 instead. That way you'll be moving the decimal point over here. If you're rounding at the 10th. So you can round at any point appropriately by moving the decimal point to that place. Okay, so that's all there is. All right, any other question?
Can you do 10, Professor?
Okay. Write a program to obtain the radius, base, and height. Radius and height, and compute the volume. All right. Okay, so here you need the pi. So, you know, it is recommended that you use constant for that. So I will declare float const pi capital equal to 3.1417. It should carry more digits than that, but I'll stop there. And then float, the other ones are not constants, variables. For them, I'm going to use float type variable for radius. Height. I abbreviated radius to rad, R-A-D. Oh, okay, and that's it. That's all we need to get from the user. And then volume is another variable I need. So let's go ahead and get the data from user. Enter radius and so on, right, all that. And the user has to enter them separated by space. So cin, user will only enter radius and height. We had to calculate the volume. So get the radius and height. And then write vol equal to pi times radius times radius, pi r squared h times height. Okay, so that will be, yeah, that'll be the volume. And we just have to write that. Volume equal to what? Now, if you didn't declare this pi as a constant, that doesn't mean it's wrong or anything, but it's the better way to write. If you used a variable for storing the pi, that'll be still correct. But if you use as a variable, then programmer, I mean, in a short program like this, it's not a problem. But in a long program, that same variable can be reused for a different value by accident, or the value of that variable can change. So if you allow that to change, accidentally it can be changed somewhere in the program. To avoid that, you make it constant. If you make it a constant, then if that is changed anywhere by accident, the compiler will pick up that as an error. So, for example, let's say I write somewhere in here pi equal to pi plus 1. Somewhere in here, pi equal to pi plus 1. That means I incremented pi by 1. If I do that, the compiler will say error here, constant is being changed. The program will not compile, will not execute, because there's an error. So if this is a question, for example, in your homework or test with a pi equal to pi plus 1, then your answer will be error. This program cannot even compile because constant is being changed. So, I just wanted to remind you about the constant. All right, so that's the program. This statement is not there. All right, anything else?
Professor, I have a quick question about pi. Do we have to just memorize like however many digits that are in the book for pi, like if we have to write that on the test?
No, you don't have to memorize that number. If there is pi involved, I will give you the value of the pi.
Okay, thank you.
Mhm. So,
Professor,
yeah, go ahead.
can you explain? Okay, so in the last line before it ends,
Yeah.
it would say like cout volume, and then it would add like go into val. When do we put like that part after volume into val? Is it? Oh wait, never mind. I think I understand it now.
Okay.
So the volume turns into like, so the right after volume, the variable and like those arrows represent like, it means it's converting it into the value for val.
No, the value of val has been computed in the previous line, right?
Uh-huh.
We computed that. So now we are saying, write the value of that variable. That's what I'm saying here.
Oh, okay.
Same volume. I called it val. And I'm writing the value of that variable right after writing this word. This word will be printed on the screen as is.
Okay.
Anything you put in double quote will be printed on the screen as is. So on the screen, you will get the answer looking this way: volume equal to whatever that number is. Okay, whatever that value of val is as well.
Oh, okay.
So there. So to get the answer with the description, I'm throwing in this word volume equal to, so that it'll appear here.
Oh, okay, okay.
Okay.
Thank you.
Mhm. Anything else from this homework? All right, then if nothing else on that, I will just move on to the next assignment, assignment 7 that you turned in today. Even though I haven't started grading it, but the material of this section will be on the test. So therefore, we are going over these questions today. Anything on that?
Can you go over number 8?
Okay. Number 8, write a program that uses least number of bytes of memory to multiply the numbers 120 and 241. Okay, notice that 120, okay, what is the largest number that fits in 1 byte? 255. 255 is the largest number that fits in 1 byte. And so any number smaller than 255 can be stored in 1 byte. Now, how do we get a 1 byte memory? by declaring a variable as char. So I can declare a variable char x and assign this number 120 and another variable y and store 241. 241 also fits in there. So I'm trying to use minimum memory, so it seems to make sense to use char to store these, but that's going to be wrong. I'm going to explain why. So if I go ahead and declare, the multiplication is the product of these two numbers is bigger than 255. So suppose that you realized it, so you declared a short type variable z to put the answer, and then you say z equal to x times y. So it looks like you took care of the problem. You know, you made big enough variable to hold the answer, but still this is not going to work. This is going to produce wrong answer. And that's actually this question in the previous question, number 6, is asking the same thing. Why is this a problem? This is a problem because having a short type variable on the left side is not good enough. 1 second, someone just entered. Maybe he's re-entering, I don't know, but we'll see. So why is this a problem? Because having a short type variable on the left is not good enough. This product is going to be too big to store in a char type variable. So when the system calculates, when the system executes the multiplication or whatever the operation you have, if both are char type, the result will be char type. This is char type, this is char type. So it will only have a memory 1 byte long because the answer is going to be char type, and it will try to store the answer in a 1 byte long memory. When it is doing the calculation, it needs to store the answer somewhere, and then you're copying it into Z. So it is, this Z equal to means you're copying, but before the copying, the answer has to be stored somewhere. So when it does the operation, char times multiplied by char will be char. It will only allocate 1 byte of memory to store that number. So whatever the number is in the binary form, it will store only the binary bits that can be stored in 1 byte. The remaining bits will be dropped, ignored. So the answer stored here is wrong answer. This only a few of the bits are stored. The actual number may have 10 bits, and you're storing only 8 bits. But it's not going to report that as an error. That's because in advanced computer science, this kind of operation of chopping off these bits is something we do. So we do use this kind of idea in programs, and therefore it's not considered to be error. Someone just came in. 1 second.
Professor, I think people are having internet issues and getting kicked out a lot, so I think that's probably what's happening.
I think so. If they are actually coming back in, and if they were here at the beginning, then they're going to be marked in on time. But I have to make a note of who is coming in anyway. Thank you for reminding me that. Anyway, so, you know, sometimes we want to chop off bits from numbers, so we use this kind of overflow ideas in advanced programming, and therefore it's not considered to be error, so it will not report that as an error. But your answer is going to be wrong because of this. So that's why this program, the way it is written, is wrong. So how do I, even though I want to use minimum amount of memory, I cannot use char. I have to make either x or y larger than char. So short maybe. It looks like short is large enough because the largest number that fits in short type is 65,535. So therefore, I can make them all short. Making one of them short is not necessary. It's not going to help in any way, because at the time of operation, this operation, if one of them is short, one of them is char, it'll convert both of them to short. So therefore, you are going to end up allocating 2 bytes of memory. So therefore, it's better to declare all of them as short. Short type x equal to 120 y equal to 241, comma ands, all of them short type, and then ands equal to x times y, C out ands. So that's your program using minimum amount of memory. Program to multiply two numbers, 120 and 241, using minimum amount of memory would be this. This is the correct answer. This one is wrong answer. It's using chart.
Professor, if you put unsigned short, that would be larger than short, right? So that
Yeah,
wouldn't be
unsigned
correct.
short allows, unsigned short makes it, yeah, actually unsigned short is the one that allows 65,535. If I don't make it unsigned short, then the largest number that fits in there is 32,000 something. So for our purpose, either one will work, right? Short or unsigned short. But you're right, unsigned short will give you a larger space. In other words, you can store a larger number in unsigned short. So unsigned short would be better. But if you write it with short, that's not going to be wrong. So either way will be correct.
Okay, thank you.
Mhm. Any other question on this assignment?
Can you go over number 10?
Number 10, okay. The following statements are part of a program, unsigned long int. So one variable is unsigned long, the other one is double. And we are doing an operation A times A plus B. And what will be the data type of the answer? That's the question, just the data type. Okay, A is double type, so A times A will be double type. And then you're adding B, B is long int type. So when it comes to long int and double, when you're adding, they have to be both converted to the larger type. And what is the larger type? That's basically what you need to remember. Double is larger than long int. Even though long int gets more memory than double, long int is considered to be smaller type. All the integer types are smaller than all the float types. So double is larger. So both of them will be converted to double. So the answer will be double type. So your conclusion is double type will be the type of the answer. Anything else?
Professor, can I go over 8?
We just went over that.
My bad, sorry.
Okay. I just wrote that here, right here. See that?
Professor, can you explain the use of unsigned and unsigned short value integers and what's the other
Just
I think
short,
big,
short,
large.
yeah, short and unsigned short. Is that what you mean?
Yeah, can you explain those and
Okay.
like the use of it?
Um,
I don't really understand still.
okay. The short int type means 2 bytes of memory will be allocated if you declare something as short. So in the 2 bytes of memory, you get all 8 bits available here for storing the number, the bits on the number. Here in the first byte, 1 bit is reserved for the sign because you're allowing sign when you declare the variable as short. So therefore, you only have 7 bits here available for the number part. Okay. So what is the largest number that can fit in here? The number that has 8 ones in the second byte and 7 ones in the first byte. That's the largest number with the positive symbol. The positive symbol will be recorded as 0. 0 will be used to represent positive, 1 will be used to represent negative. So anyway, it doesn't matter whether what the sign is, you only have 7 bits here. So that means the largest number has altogether 15 bits. So if you convert it to decimal form, 2 to the 0 plus 2 to the 1 plus all the way to 2 to the power 14. Because there are only 15 bits, so the largest power will be 2 to the 14. And we learned the formula to add these up. And that formula, let me write that formula, 2 to the 0 plus 2 to the 1 all the way to 2 to the power n is equal to 2 to the n plus 1 minus 1. You need to remember that formula to be able to do this kind of calculation. So that'll be 2 to the 15 minus 1 by using this formula. And that's going to be 32,000 and change. I can actually get that correct number. I did that in the last class, but I'll go with that. I'll calculate that again for you. 2 to the power. So by the way, you need a calculator, scientific calculator that allows exponents. Okay, after subtracting 1, you have 32,767. So the largest number that fits in this science short, the short is 32,767, but now negative numbers are allowed. So the smallest number that fits in there is negative 32,767. So the range of numbers would be this for a short type memory. But if you declare it as unsigned short, what you're doing is when you declare a variable as unsigned, you're saying I only have positive number, so I don't need a signed bit. So that's what this means. So now the variable x will have all of the bits available in the 2 bytes. So that means your number that will, the largest number that fits in here will have 8 bits in the second byte and 8 bits in the first byte as well. So this is the largest number. If you calculate the decimal equivalent, that will be equal to 2 to the 0, 2 to the 1, all the way to 2 to the power 16. Wait. No, 15. The largest power is 15 because there are 16 bits. The value of that is 2 to the 16 minus 1. And 2 to the 16 minus 1 is 65,535. So a much larger number fits in there. Here the number is smaller, about half. So the range of numbers that fit in unsigned short would be 0 to 65,535. So that's the difference. When you say unsigned, you are saying, I don't need to reserve a signed bit because my numbers are positive. So it'll give you all the bits for your number. And so the number that fits in there is larger, 65,535. Okay,
Ooh.
that, Benjamin?
Yeah. So when I write a program with it, what is the use essentially? Just this, like for like larger bits?
Yeah, one more bit is available, which means your size of the number that fits in there is can be up to 65,000. So if your numbers, after you multiply and add or whatever you're doing, if your number can reach more than 60,000, then using unsigned short is beneficial. It'll work, right? You know, you can make it work. When you use normal, yeah, when you use just short, your numbers have to be limited to this. Even
Oh,
answers you produce have to be limited to this, right?
yeah.
That's the advantage.
Okay, thank you.
And so I assume there's nothing else on this assignment. So let's go on to doing the review exercises. So let's go page by page. Any question from page 1? Okay, page 2. I assume you have all done these, only if you have done them, then when you get your questions answered, you will be learning from that, and it'll stay in your head only if you have done them.
I just have a quick question about the hexadecimal coded question. Are we going to have the the A equals like 10, B equals 11 conversion on the test?
Of course. If I ask you to write, if I ask you to code a number using hexadecimal code, then you're going to have to use those letters and numbers mixed. Yes, of course. So you need to know that 10 will be written as A, 11 will be written as B. All those you need to know. Yes.
Okay, so we have to memorize that.
Yeah,
That was
you
my question.
memorize. Exactly.
Okay, thank you.
Mhm. Okay, nothing on page 2. Moving to page 3. Okay, moving to page 4.
Professor, can you do 79?
79, okay. Write a program that obtains a floating point type number from the user and prints the first digit found after the decimal point. Okay, there are many different ways to achieve that. So whatever method you can come up with is good enough if it works. I'm going to use my own method. We need to get the number from user and then print the 1 digit, okay? So since it says program, you had to begin with main and write all the entire body. So declare a variable float type to hold that value, X, and then we're going to get 1 digit out of it. Maybe we will need an integer type variable at some point. So declare that and ask the user to enter the number. C in X. So now user has entered the number. So the number is something like 25.732. Then this 7 is what we need to get. So different ways there. You know, you can take the fractional part, and then you can first extract the fractional part and then get the first digit of it. There are different ways, but I'm going to approach it this way. I'm going to multiply by 10 to move the decimal point over, and that'll become 257.32. And then I'm going to pick up integer part of it, which will be 257. And then I can extract the last digit. What is the easiest ways to extract last digit of an integer? Anybody remembers? We went over these in class. No one remembers?
Can you repeat your question?
The question is, I have an integer number. I want to extract last digit of it, the 7. If I extract that 7, that's my answer. That was supposed to be what that's what I need to print. So how do I extract last digit?
Do you do module, is that what it's called? Like
Modulus with
100 or
Operator.
Yeah, modulus operator with what number?
10.
10 is right. Modulus 10. Because if you do modulus 10 with the 257 modulus 10, when you divide 257 by 10, how many tens are there? 25 tens. So 25 tens, 25 times 10 is 250, so the remainder is 7. So 25 modulus 10 is equal to 7. The modulus operator produces remainder. So modulus 10 always picks up the last digit, no matter how big the number is. The modulus applies to integer numbers only, and that's why I can't apply on this number here. I can't do it here. I had to pick up the integer part and then apply the modulus 10. So that's what I'm going to do. I'm going to multiply the x by 10 and store it in y, which is integer variable. Now take the y and modulus 10. Take modulus 10, that'll pick up the last digit. I'm putting it back in y. So y now has that digit I need. This is the digit I needed, and I got that by multiplying by 10, I got this. and take the integer part and take the modulus, that'll pick up 7. So C out to Y. That's our answer. So, just by multiplying by 10, dividing by 10, use modulus operator, by using all these different things, you can achieve almost any of these tasks of separating a digit from a number. Anything else?
Can we go over 74?
74, okay. 74 says int n1 equal to 9, n2 equal to 2, float s. Let me write that. I'm going to write the part that says s equal to an expression s equal to n1 divided by n2 of the c's times 2.0. Okay, whenever you're doing any operation, any arithmetic operation, pay attention to the data types of both operands. Here, n1 and n2 are both integers. So you're dividing 9 by 2. The integer divided by integer will be integer. So the answer will be a 4. So you're multiplying the 4 by 2.0, which will be 8.0. The answer will be float, but it's not the answer you expected, because 9 over 2 is not 4.5, it's 4. So S has 8.0 in it, and that's what you will be printing. So the output is 8.0. If you write
Thank
8
you.
point, that's correct too. We write the 0 behind the decimal point to highlight the fact that there's a decimal point here. Yeah, if in the test to write your output, there will be, it says output, and it'll have a box. You enter the output only. You don't write s equal to 8.0. That'll be wrong. These questions, Blackboard is going to grade itself, and if you write anything other than 8.0, it's going to mark it wrong. So only 8.0. It's been programmed to recognize that 8.0 and 8 point are correct answers, but anything else will be wrong. Okay, any other question? All right, moving to page 5.
Can we go over 89?
Okay. 89. It's about the value of an item. Now, what this problem tells you is fact. It is true. If you know the purchase price, let's use car as an example. A car has a purchase price like $20,000, and then life of a car is normally about 13 years. So after 13 years, it has scrap value. Scrap value means, you are dumping the car now, the scrap yard will pay you something, and like $1,000. So that's your scrap value. And if you know those numbers, usually we know those numbers for cars. So if you know those numbers, length of life, 13 years, scrap value, $1,000, purchase price, whatever you paid for. Using that, we can calculate the value of that car at any time in its life. And this formula illustrates how to do that. So we are going to write a program that will calculate the value after 6 years by using this formula. So I need to get these numbers from the user. For the item that we are working with, we need the purchase price, scrap value, and the length of life. Okay, so we begin with main. Pick up the pencil. Begin with main and write declaration of the variable. So float type variable for price, which is purchase price. Scrap for scrap value, and then feature value or means, value at any point in time, I'll call it f value, to mean future value. Semicolon, and then in type variable for years, life, that is, I'll call it life. Okay, as for, we need another variable for f. We're supposed to store f somewhere, so f, I'll declare it as a flow type variable. So now we need to ask the user to enter those numbers that we need. Enter price, scribe value, those three numbers, and the life, length of life. Three numbers user has to enter and read them into price, scrap, life. After that, we need to calculate that f. F is price minus scrap quantity divided by life, length of life. Then the future value can be calculated as by the next formula, value after n years equal to purchase price minus NF. So F value, the value after 6 years, equal to the price minus 6 times F. And now we are ready to write the output value after 6 years equal to F value. And that'll be it.
So for problems where we have to get information from the user, are we're able to just combine everything in one line like that, or did you just do that because you were writing quickly?
Oh yes, you can combine all of them in one line.
Okay.
The CN statement can be written to receive any number of values from keyboard. Only thing is the user will have to separate them. Like the price, let's say that's 18,000. Then user has to enter 18,000 separated by a space, and then write scrap value 1,000. There must be a space in between. So you need to say that in your statement. I was brief here, but in an actual program, you had to say enter price, scrap value, and life separated by space. Just make it clear to the user that he has to enter a space.
Okay.
All right. As long as he does that, everything will work fine. So yes, when you write a program, you can write one line to get all the data like that. Okay, anything else? Okay, so if there is no other question, there are a few things I need to say about the test. And test is next class, and your test, your class time is going to be 9:25, but I'm going to send you a new link for the test, and because the usual class meeting link, do not use that for the test. A new link will be sent. And that link will tell you that the test starts at 7:30 a.m. That's because this test for the other class starts at 7:30 a.m. So if you want to start the test at 7:30 a.m., you can do that. If you prefer to finish it earlier, so you can start anytime. It'll give you 1 hour, and the total maximum time allowed is 1 hour and 45 minutes, half an hour extra. So no matter when you start, in exactly 1 hour and 45 minutes later, it will submit itself and turn off. After that, you won't be able to work with the exam. So you can start early if you like, and then it'll finish early. If you come late to the class, instead of 9:25, let's say some of you came late today, and if you do that, it'll give you the 1 hour and 45 minutes time, no matter when you start. But if you have another class after this, then you may have to quit in between before finishing the test. So recommend if you think you are not going to be able to make it on time at 9:25, then you may want to start the test at 7:30 and be done with it before 9:25. And the other thing is, you must have your computer, you must join the meeting to do the test. You must be in the meeting. You cannot take the test outside the meeting. There will be a password, and I will only give the password to those who are in the meeting. And also I must see all of you, like I mentioned in the last class. So your video must be on. If you don't turn on the video, you are not going to be allowed to take the test, because I have to see who is taking the test. And I have to see exactly what you're doing. You're not supposed to be doing anything other than doing the test on the screen. Even on the computer, you cannot use any other software or any communication media, or email, or anything like that. You're not supposed to do any of that. And no notes in front of you on the desk, and no stick notes on the computer monitor, and no communication media. No, you should not have the cell phone in front of you. You are allowed to have a calculator. You actually need a scientific calculator. So you need to have scientific calculator in front of you and a scrap paper to do the work. You're only entering answers for most of the questions. Only for the program, you're typing an entire program. So since some of you are slow typists, I'm allowing you extra time. That's the only reason I'm allowing extra time. The test is not going to take 1 hour and 45 minutes. It'll take only about an hour. The reason for allowing extra time is because some of you are slow typists, and I'd have to accommodate that. So your time is given to you for just to work on the program. And if you are going to be communicating, I explained to you in the last class, I did have students cheating in the last semester. Altogether, there were 6 students cheated, and all 6 of them I failed because of the cheating. And I'm trying to avoid that this time. Only if I give you an opportunity, you end up cheating and then end up failing. I don't want anybody to fail. So please only do the test during the test time. If you violate that rule, you fail the course, not the test. Not just the test, you fail the course. So remember, no communication with anybody else during the test. No communication device can be used. No emailing, none of that will be allowed. Okay, so that's all I need to say. Any other question about the test? Okay, anything else that we should go over?
Is the test multiple choice? Will there be, or is it all short responses?
No, there are all the variety of different kinds of questions. Most of the questions are going to be answers you have to write in a box. It'll say, place the answer here, and that'll be a box. You write the answer, and there will be like a few multiple choice, like 4 or 5. I don't remember exact number. Not too many. And there are fill in the blanks. And again, fill in the blanks means the blanks will be boxes where you enter the words. Certain words are expected. So you have to have the technical words correctly. For example, let's say the question says it's a multiple choice, not multiple choice, a blank, fill in the blank question that says a program is a set of what? Then you had, what is the key word? Anybody? Instructions. So you don't say program is a set of program. That's another wrong answer I get all the time. So the certain keywords are expected, and so you need to enter those in the boxes. So some of them will be, most of the time it's a box where you enter the answer. It can be a word or a number, depending on the question. And then only about 10 questions will ask you to write C++ statements to represent something like this one, 90, question 90. Write this in C++, this expression in C++. Then you only write that expression in C++. You don't write a whole program. But then there are 3 questions that will ask you to write program. So for those, you begin with the main, like this program I just wrote on the board. You write that whole thing, beginning with the main. So that's the only place where you're doing some significant typing. And also remember, when you're typing with the on the blackboard, do not use the tab key. Tab key throws the cursor all over the place. Just use space key to get blank spaces, no tab key. Other than that, it'll work like any other typing. Yeah, so that's it. So yeah, there will be boxes where you type the answer. So most of the time, the answer doesn't take too much time. Like if I ask you for a hexadecimal code, you calculate the hexadecimal code on the sky paper and enter the answer in the box. You're not showing any work for those. All right, I hope I answered the question. Anything else?
I just want to clarify. So you're saying if it says write a program, that's when we start with main and the
Yeah,
brackets. But if
right.
it just says write a statement, then we just write enough to get that answer.
Exactly.
Okay.
Exactly. So for example, let's say one question says, writes the variable val has some value stored in it. Write statement to replace val with the fractional part of the original val. So like if it has 7.67, you want to replace with 0.67. So if that's the question, then you need to write val minus int val goes back in val, right? From val, you subtract integer part of it, then you'll get only fractional part, which goes back in val. Then you have replaced val with the fractional part. So this line with the semicolon, that is your answer. So just that statement. So whatever the statement necessary, that's all you write for those questions. Only when it says write program, you have to write a whole program. Okay. Okay, so we are running out of time now. So, so remember the policies I just announced. Like I said, last semester, I had one section and 6 students were failed because they violated the rules. So don't get into that, just follow the rules, then you'll be fine. All right, then I'll see you Monday, and good luck in the exam, and enjoy your weekend, and enjoy the rest of the day. Now, remember, like I said, you can start the test earlier if you like, and you will get exactly 1 hour and 45 minutes. And also one other thing, I said I'm going to allow you to do only one problem at a time and not allow you to go back to it. My other class students didn't like that idea, so I'm reconsidering. So I don't know, at the beginning of the test, I will tell you whether you'll be able to see. If you're allowed to see all of the tests, then you'll be able to go back and forth, by scrolling. But if you're not allowed to go back to the other problems, you will be only seeing one problem at a time, and you can only answer one problem, and you won't be able to go back to it.
Professor, I think I kind of agree with that, just because for me, I personally, if I get stuck on a question, I feel like I might waste more time on that question. So I think if I move on from it and then go back to it, I think it's more beneficial, because I waste less time, and I could just, if the answer ever occurs to me, or once I'm done with the test, I could go back to the ones I haven't completed. I think that helps more.
I agree with you. I was a student once. I took exams, so yes, I like that too. I skip all the harder ones and do all the easy ones first. I do that, and then go back to the harder ones and take the time, which is a good strategy. And so I do. understand that, it's that cheating that made me change my policies. But I'm rethinking about it. I may end up letting you go back to the previous problems. So we'll see.
Thank you.
You're welcome. Okay, have a nice day and weekend. I will see you Monday.
Thank you. Have a good one.
You
Thank
too.
you, Professor.
Thank you, Professor.
Yep. Bye now.
Hi, Professor. I just wanted to make sure that you saw my name in the beginning of class because I was here. I don't know what happened, but
Oh, okay. So you were here at the beginning and you had to come back in. Did you? No, you were, yeah, I marked you in time.
okay, good. Just wanted to double check. Thank you.
You're welcome.
Professor, just two questions.
Yeah.
So like one is like for questions regarding like what is same like the dimes and nickels. So would it be fine if we declare them as float?
Yes, nothing wrong with that because your final value is going to be floored, so it doesn't really matter. Yeah.
Okay, and also like the ASCII code table, would you provide us with one, or
ASCII code.
like the table, would you provide us with one, or like
The decimal equivalents, yes, the capital A corresponds to 65. Yeah, that'll be given on the test. Like this, yeah, it's not on the review. On the review, I was looking at the review. Yeah, it'll be given on the test, so you will have that.
all right, thank you, Professor, have a good one.
Yep. Bye now.